I'm going to say something, but I'm sure.
Well, I will tell you what I tell graduate students that come see me and looking for advice on what fields they should work on. And I have to tell you my own personal story, because when I started to do physics in a professional lab in graduate school, I went to see these physicists and they were all depressed, right? It was the beginning, it was 1971, and the funding at that time was severely cut in physics. And they said to me, well, you shouldn't do physics, you should do biology. This is the science of the future. Well, I went to biology labs. I even studied biochemistry, but it was much less fun than physics. As John says, in physics you get to work with a lot of interesting things, like that you smell oil in the machine shop, you solder, there's some. I mean, the tactile environment is much more interesting in physics than in biology, I think. So I thought, well, this science that physics has been going on for 2,000 years, maybe it will last a little bit longer than my PhD. Let's have fun.
Make it a little bit more optimistic.
Yes. It was important to have fun, and so I think this is really important, is to try to go to the place where you think you will have more fun. Don't think too much about strategizing, which science has a future, which one is decadent. All these things change very rapidly, so you should try to get a good physics education first.
Yeah, and I heard at the time that maybe people thought condensed matter physics was kind of dying out at the time because they had figured out semiconductors, superconductors, a lot of things. But if you look at what happened, is people invented these, mesoscopic, other things. They invented new devices and new physics to see it, and then it exploded, greatly. I think the same thing happened with AMO, atomic molecular optical physics.
The atomic physics is like the phoenix. Is rebirth always from slashes.
So what happened in my case is that I talked to professors, but I talked to John Clark, and they were doing quantum mechanics of these electrical systems, which I thought was fascinating. And I don't know if I had the right intuition or not, but it sounded really interesting. Joined this group with the conferences. I saw what the people were talking about, and it's like, well, maybe I was naive. Well, we could do that, But I did go to John Clark and say, I'd like to do this. And he said, well, the experiments have already been done. And, which is, you have to do something new in science. But then John, and I think Michelle and I, we thought about it a lot and said, well, how can we do it differently? Okay, and doing it differently and measuring all this just kind of created a field, because then you saw how to do things. And we were very lucky because this physics, experimental physics, was very clean. We ever built a quantum computer in the end, which was not at all obvious at the time for many of the data. So you have to be, always interested in figuring out what's going on, see things, and then if something really interests you, you try it. And sometimes it works and sometimes it doesn't work. And then as you get older, you get a better sense of what's, the forefront, what you can do. And it's also being kind of lucky to choose the right thing to work on. But you guys knew at Clay right away that this would be a big field. And they started the whole group on this.
Yes, I have to make the record straight. I have to admit that in between the beginning of my graduate studies and the end, there was the oil crisis. So all of a sudden there was much more money in physics.